Okay, so hi everyone. My name is Lisa Yee and I'm from the Faculty of Nursing and I'm the apper in our group. And then our programmers are Sean Weeb from Biomedical Engineering and then we have Clyde Wheeler from Aerospace. So the app we created is called Pupl. And the motivation for Pupl is really to create an app that's useful for clinicians to use in the healthcare environment. In the hospital, especially where I work, neurological assessments are done quite frequently, every 1 to 4 hours for each patient. So these assessments are performed to give us an indication of overall brain health and the level of consciousness. So what's really going on inside the brain is hard to figure out from the outside. So there are a number of non-invasive techniques that are developed, tools and assessments that are developed so that we can figure that out. So using these sort of non-invasive techniques, clinicians can figure out whether a patient might need more medical attention. Maybe they need a CT scan or something a little more invasive. And the idea is if we can gain objective data, we can initiate treatments earlier and potentially save lives. So within the assessments, our app is going to focus on level of consciousness and pupillary light reflex. These two assessments are often done together, so it's made sense that our Pupl app would do the same. For level of consciousness, we're going to talk about a validated scale called Glasgow-Coma scale. I'll expand on that a little bit in a second. And then the pupillary light reflex, what we're concerned about is the speed of constriction for your pupil, and then also pupil size. So focusing a little bit more on what Glasgow-Coma scale is, or GCS as we call it, it is the most objective way of recording a patient's level of consciousness. So based through a series of questions and of observations, you can figure out the patient's best eye, verbal, and motor response. And it's scored out of 15. And based on the score that you get, you can sort of assess the level of injury. So something like a GCS less than 8 would be severe. And then finally, the pupillary light reflex, which is your pupil constricting in reaction to light. The basic method of performing that assessment is using a flashlight. That's cheap and easy to access, but it is a subjective per clinician assessment. And then more advanced methods are available. For example, this neuroptic NPI pupillometer. This device is objective in terms of measures the speed and gives you a value, but it's very expensive. It's about $6,600 for 1 unit, and they are hard to access. So for example, at St. Michael's Hospital, which is a teaching hospital downtown, there's only one available in the whole hospital. So the goal of Pupl is really to make an app that is accessible, inexpensive, and objective to help clinicians perform these neurological assessments.
Yeah, so Pupl has 4 primary sections. The first one you see on our right here, this is our session manager. The user can quickly select a patient from their drop-down menu and then jump into one of our other 3 sections there. Patient manager for managing the patients that are in the app, the test center for conducting our Glasgow-Coma scale and light reflex, as well as patient history viewer to view past results. This is done through 3 kind of technical components in the back end: a database for all the storage of the information, a library of code called Open Computer Vision. This we use for our pupil detection algorithms to determine the size, as well as a library of code called GraphView used for plotting, which you'll see more of in the demo here.
Great. Do you want to bring the chair?
Yes.
So in our demo, okay. For our demo, Sean is going to be our patient, and myself and Clyde are going to be the nurses. You can actually face me.
Okay.
Yeah. Okay, so in the app, as you can see, I'm just gonna, can you guys see the app okay? Okay, so I'm gonna go into the patient manager. We're not working with Bill today, so I'm gonna look for Sean. Here he is. So I can, we can also see when he last did his test, which is helpful, 15 minutes ago, but we'll do it again now. And we can also move through this like quick drop menu to make sure that we're with the right patient. So I'm going to go right into the test center. And the first screen is through the Glasgow-Coma scale test. So hi, Sean. How are you doing?
Well, thank you.
Good. So my name's Lisa, and this is Clyde. We're going to work with you today. Do you mind if I ask you a few questions?
No, not at all.
Great. Can you tell me your full name?
Sean Weeb.
Great. And do you know where you are right now?
At the University of Toronto.
Great. That's correct. And do you know the date today?
Yeah, May 3rd, 1967. Leafs just won.
Not quite. It's actually April 8th, 2015. Yeah. Can you just give me a thumbs up? Perfect. Okay, so through that interaction, pretty quick, I can input some data. So I'm going to go through the quick input because it moves through every screen for me. So the best eye response, Sean's eyes were opening spontaneously, so he gets scored a 4. Best verbal, he was confused and disoriented, scored a 4, and then best motor, he was obeying commands well, so 6. So it tallies it for me, and it will keep track of this for me so I can track over time. So he got a score of 14 out of 15, which is within normal range. And then Clyde will move through the next part.
All right, so this is the light reflex test. And what you do here is you try and fit the patient's iris within this red circle here. And then since this is the patient's right iris, I'll hold down the right button. And it'll start looking for the pupil. And you can see that indicated by the green circle here. And once I'm confident that it's found the pupil, I'll release the button, which will start the test. It'll start recording a video. And it'll also flash the light on and off, which causes the pupil to constrict. And right now it's going through this video frame by frame, looking for the pupil in each one of these frames. And it's measuring the size of the pupil in each of these frames. And it's also, when the light's turned on, measuring the constriction speed. And once it's finished, it'll pop up with a results screen, which you can see here, and it's got a playback of the test. And as you can see, it does lose the pupil due to the huge change in contrast immediately after the light turns on, but it regains it. And you can see here, it reports the pupil size, the constriction speed, as well as the response. It should be brisk, but I think the lighting wasn't good enough in here. And on the bottom here, you can see a graph if you want a more detailed picture. And you can see that the pupil does constrict and then returns to a normal value, although there's a lack of data points in this region just due to the huge change in contrast. So I'll save these results. And I won't do the other eye for now, so I'll finish. And that concludes our testing. And say I wanted to go and compare these results to past patient results, I can go into patient history, which gives me a graph of all past Glasgow Coma Scale results, as well as the pupil size for each eye, and the light reflex results. And you can scroll through this list here if you want the actual numbers. So that concludes our demo. Right. So a large part of our learning over the development of pupil actually comes from going to the hospital and testing out the neuroptic MPI pupilometer, which Lisa mentioned earlier. And you can see us doing this here on Sean on the image on the right there, and comparing its results and its functionalities with our own app, Pupil. And what we found is that Pupil's got a lot better user interface and user experience in terms of patient selection and viewing. And this is largely thanks to a touchscreen interface, which the MPI pupilometer does not have. However, we're also constrained to use just a regular camera as opposed to an infrared camera, which makes things like glare, dark irises, and poor lighting conditions have a huge impact on how well we can detect pupils. So this was a large challenge for us. Another big challenge was developing a valid methodology for classifying pupil response into brisk, sluggish, or absent. Currently our methodology is based on just a single paper, but we would prefer to do a lot more testing on actual patients in order to validate this. And going beyond this course, if we continue working on this app, we hope to refine, hopefully perfect pupil detection so that it works on a wide array of patients regardless of lighting condition or iris color. And as I said before, we want to validate our algorithm for classifying pupil response. We also want to provide more comprehensive statistics to the clinician so that they can make more informed decisions with regards to a patient's treatment or health care. And finally, we want to integrate our app with secure hospital servers to provide a seamless user experience for healthcare professionals. Thank you. Are there any questions?
Hey, that's really great. It's exciting. The test is very interesting. The data showed something going like this and then went like that.
Yeah.
Like that. You didn't quite explain. That was the measured size, radius of the pupil, or diameter?
Measured diameter. So I think you could see it lost the pupil in a large number of those frames due to it's a lot darker today. So I think that was mostly due to the poor lighting conditions. And as a result, it only got a couple of data points in that sort of spike downwards.
But the lighting conditions are with the flash on. Are they not?
Yeah. So it does still have to do with the ambient lighting conditions, though. The flash will turn on, but just more global illumination I found does help.
The automatic gain control in the camera won't react as fast as the flash. So if it's a dark room and the flash comes on, it's actually like, that's the worst case for you guys, actually.
Yeah.
Right. But if you had an infrared camera, your life would become much better.
Oh, yeah.
So that's actually coming pretty soon, we all think, or we hope.
I've actually tested this. It does pick up some of the infrared bands. I've tested it on like a TV remote, shining it, but the sensitivity is not quite good enough.
Yeah, soon there may be lots of availability of that, maybe on the front-facing camera.
Yeah, that would be cool.
There's a thing coming out called, I don't know if we've talked about it, called an RGBI camera.
Okay.
Which the eye is infrared.
Oh.
So it's all, what's nice is it's all combined into one, and you could just look at the infrared channel if you wanted.
That's cool.
So they apparently exist already. Great, nice, really nicely put together. Questions or comments, suggestions?
I know you can get like small lenses or things like that to put on your phone. I wonder if you guys looked into that hardware to help solve your glare issues and stuff.
I actually bought one of those clip-on macro lenses, and it did help a little bit with dark irises, but we were demoing with sort of light eyes anyway, so it was fine without.
And it also tended to block the flash.
Yeah, it depended on what the setup on the back was for you. And I guess it depends on which one attachment you buy.
I really like the results screen. That was really intuitively laid out with the video playback and the graph and the speed stuff was really cool.
I think speed and being able to put it in is a really good factor. I think you guys did a really good job with like the tap where it just automatically brings up the next field where you say it's either sluggish or red. You guys did a really good job with that for speed.